Hello, hello, hello. We are back with Chapter 6, Lesson 3, Using Properties with Rational Numbers. So for example 2, we're going to be writing equivalent expressions. But it's actually equivalent equations. So I'm going to cross that out and write equations. So I want you to go ahead and do that as well. Okay? So it says, write an equivalent equation for 3/4 x plus 7 equals 5/6. Okay, so 3/4, I'm going to write it down. That does not contain fractions. So we're going to write an equivalent equation that does not contain fractions and then solve the equation. So I'm going to teach you a pretty cool trick. Okay, we're left with this equation, 3/4 x plus 7 equals 5/6. Now, we've done a lot with equations and solving. This is a two-step equation. I know that you can solve this, but I want to teach you a way in order to get rid of the fractions. So we're going to rewrite this equation so it no longer has any fractions at all. Now, the first step to doing so is you need to find out what the LCM is. And remember, that's the least common multiple. So what that means is when you count by 4s and you count by 6s, it's the first, you count by multiples. So multiples of 4 would be 4, 8, 12, 16, 20. And when you have multiples of 6, 6, 12, 18, and hey, right there, 12 is our least common multiple, okay? It's the smallest one they both have in common. So what that means is we're actually going to take this entire equation, this side of the equation and this side of the equation, and we're going to multiply it by the least common multiple, which would be 12. So we're going to multiply it by 12 to both sides. So I'm going to go 12 times 3/4 x, 12 times 3/4 x. Then I'm going to go 12 times 7, so I'm going to go plus 12 times 7 equals 12 times 5/6. So 5/6, I'm going to multiply it by 12. Okay? Now when we do this, I want you to look and see what happens. So this first part right here, we're going to make this 12 into a fraction. And whenever we're multiplying fractions, we look to cross cancel. So is there a common factor between 12 and 4? Yes, 4 is. So 4 goes into 4 one time. 4 goes into 12 3 times. And we can't cross cancel anything there, so we're just going to multiply across. 3 times 3 is 9. And then 1 times 1 is just 1, so 9 over 1 is 9. So it's 9x, okay? So yeah, I had a fraction, and now that fraction's gone. Now it's just 9 plus 12 times 7. Now, I'm not sure what that is off the top of my head, so I'm going to go over to the side and go 12 times 7. 7 times 7 times 2, I'm sorry, is 14, right? The 4 carry the 1. 7 times 1 is 7, plus 1 is 8. So that ends up being 84. Equals, I'm going to make this 12 over 1 a fraction, and then I'm going to look to multiply these fractions. We'll look to cross cancel first. Nothing I can do there. But the 6 and the 12, is there a common factor there? Yes, there is. It's 6. So 6 goes into 6 one time. 6 goes into 12 two times. And then I just multiply across. So 5 times 2 is 10. And then 1 times 1 is just 1, and 10 over 1 would just be 10. So there we have it. I have my equation. I had this original equation with fractions. I multiplied it by the least common multiple between the numbers on the bottom of the fraction of 4 and 6 here. So I counted by 4s, counted by 6. I found that it was 12. I multiplied everything by 12, and I ended up with this two-step equation. And now I'm just going to get x by itself. I know that these two are going to have to be together till the bitter end. So that means I need to get rid of this positive 84 by doing the inverse operation, which would be subtracting 84 to both sides. Now I have a positive 10 and I have a negative 84, so I know that the signs are different, and so we got to take the difference. So we're going to take the difference between 84 and 10. 4 take away 0 is 4. 8 take away 1 is 7. So my answer is going to be 74, but I need to figure out if it's a positive 74 or a negative 74. I look at 10, I look at 84, and 84 is negative, which means our answer is going to be negative. Those cancel each other out. We're left with 9x, and we need to get x by itself, and there is a 9 there, so now it is time to get rid of the 9. How is the 9 related to x? It's related to x through multiplication, so I have to do the inverse operation of multiplication, which would be division. I'm going to divide both sides by 9. 9 divided by 9 is 1. 1 times x is x. And I am left with negative 74 over 9 as x. Now, I'm not sure if we can reduce that at all. I don't think the thing would be to see if 3 goes into 74. 7 plus 4 is 11, and 11 doesn't go into, 3 doesn't go into 11. So it's not divisible by 3. So I really think this is our answer right here, negative 74 over 9. Now we could write this as a mixed number if we went and said, well, how many times is 9 going to 74? And it goes in 8 times, because 8 times 9 is 72. So we could say it's the same as negative 8, and if 8 times 9 is 72, there would be 2 left over. So it would be the same thing as negative 8 2/9. However, we could just leave our answer like this, and that would be completely fine. All right, so let's go on to another example here. Check it out, example 2. We're going to write an equivalent equation for 1/2 x plus 9 equals 4, 6. So I'm just going to rewrite the problem first. Plus 9 equals 4, 6. So the first thing I need to do is figure out, well, what is that LCM? The least common multiple between 2 and 6. So if I count by 2s, 2, 4, 6, well, hey, there's 6 right there. So 6 is going to be the least common multiple, which means I'm going to multiply both sides of the equation by 6. So I'm going to go 6 times 1/2 x, so 6 times 1/2 x, and then I'm going to go 6 times 9, so plus 6 times 9 equals 4, 6 times 6. Now these 6's, I'm going to change those into fractions by going 6 over 1. Now I'm going to multiply these fractions together, so I'm going to look to cross cancel. So is there a common factor between 6 and 2? The answer is yes. 2 goes into both of these. 2 goes into 2 one time, 2 goes into 6 3 times. Then we just multiply across. 3 times 1 is 3. 1 times 1 is just 1, so it's going to end up being 3x plus 6 times 9 is equal to 54. Equaling, okay, now I have to do this for 6 times 6. I'm going to make that 6 over 1. I'm going to look to cross cancel first. The common factor between 6 and 6 is just 6. 6 goes into 6 one time, and 6 goes into 6 one time. Multiply across, I get 4 times 1, which is 4. And then 1 times 1, which is 1. So 4 over 1 is the same thing as 4. Now I'm just going to isolate x and get x by itself. I have my equations, my equation with no more fractions, so that's really nice. So it's a nifty little trick. I'm going to leave this 3x together till the bitter end. So I need to get rid of this 54, so I'm going to do the inverse operation of adding 54, which would be taking away 54 to both sides. Now when I do that, I have a positive 4 and I have a negative 54, so the signs are different. So that means I need to take the difference between 54 and 4. And I know that the difference between 54 and 4 is just 50. And then I'm going to look and see if it's a positive 50 or a negative 50. And since 54 is bigger than 4, my answer is, and 54 is negative, that means my answer is going to be negative. Okay, so positive 54 and negative 54, they cancel. I drop down the 3x here. And then now I'm just trying to get x by itself. And so I have 3 times x. The inverse operation of multiplication would be division. I'm going to divide both sides by 3. 3 divided by 3 is 1. 1 times x is x. And then I'm left with negative 50 over 3. I can't simplify that, so that's an okay answer. The higher you get into math, you're going to have answers like this, and that's okay. Now I can change it to a mixed number if I figure out how many times 3 goes into 50. I'm not sure how many times, so I'm just going to go 50 divided by 3 real quick. 3 goes into 5 one time. 1 times 3 is 3. 5 times 3 is 2, and then I drop that 0 down. 3 goes into 20 6 times. 6 times 3 is 18, and then there's 2 left over. So that means 3 goes in there. It would be negative 16 times with 2 left over. So this would be my number as my answer as an improper fraction, and that would be my answer as a mixed number. But leaving it as an improper fraction is totally satisfactory. So yeah, okay, we will see you next time. Goodbye.